All right, so 3.4 measures of position and outliers. Z-scores would be the distance a data value is from the mean in terms of standard deviations. So we'll be using these with more application later on in the semester. So this is just an introduction to Z-scores. We will be calculating today. And yes, I had one of your classmates ask me a private question. The answer is yes. So Z-scores, the distance a data value is from the mean in terms of standard deviations. So the general way that you will be calculating your Z-score is to take your data value, subtract the mean divided by standard deviation. And so whether you're dealing with the population or the sample, you may have different symbols. Remember we talked about that, might have been last class or class before last, talked about different symbols that you have for your population versus your sample, but it's still the same thing. So in other words, X is your data value, your population, your mean would be mu, but for your sample, your mean would be X bar, and then divided by the standard deviation. For population, that's sigma. For the sample, that's the letter S. But regardless, the process is data value minus the mean divided by the standard deviation. And like I said, the population and sample will have different symbols, but it still represents the same thing. So the Z-score is unitless and it has a mean of 0, standard deviation of 1. So basically when we go to our Z-score chart, and like I said, we'll talk about that more, probably around either chapter 6 or chapter 7, probably chapter 7. 0 will be in the middle because your mean is always in the middle, and then it will, deviate from that. And like I said, we'll talk more about it, but just give you a few statements that my math lab may ask you. So just as conceptual questions. So your Z-score is unitless, has a mean of 0, standard deviation of 1. All right. So first example, determine whether the Angels or Rockies had a relatively better run-producing season. The Angels scored 773 runs and play in the American League, where the mean was 677.4 and standard deviation was 51.7. The Rockies scored 755 and play in the National League, where the mean was 640 and standard deviation was 55.9. I think I got a little lazy with writing that one, but yep, I'll give you guys a chance to write that for those who are going to write it. All right. So while you finishing up, so we're looking at two different teams. They play in the Major League Baseball, MLB, yeah, Major League Baseball. Um, but one play in the National League and the other plays in the American League. And if you know a little bit about baseball, they have a little bit different rules when it comes to how you score and how you hit and all the stuff like that. So that's why they're separating the two. And so the Angels, they scored 773 runs and play in the American League, where the average and the standard deviation was different. And the Rockies play in the National, and their standard, standard deviation, was a little different as well. So this is the information that we know. Got 773 for our data value for the Angels, with a mean 677.4, standard deviation 51.7. Then for the Rockies, 755, how many runs they scored. 640 is the average, 55.9 is your standard deviation. So we're going to find the z-score for each. For the Angels, 773 minus 677.4 divided by 51.7, and that'll give us 1.85 for the standard deviation. Then for the Rockies, 755 minus 640, and that's a 0.4 down there. That should be 0.4. That should be a 0. 640.0. And then divided by 55.9. That gives us 2.06. And also something that we're going to hold to is we're always going to round our z-scores to 2 decimal places. All right. So what does that mean for us? So this means the Angels scored 1.85 standard deviations above the mean, and the Rockies scored 2.06 standard deviations above the mean. So, doing your z-scores, what it does is it take your data value, in this case, your run score, and compares it to the mean. And so even though the Angels scored 773 runs and the Rockies scored 755, which was less, if you compare it to the mean of the league that they were in, the Rockies scored 2.06 above the mean, which is more than what the Angels did above the mean. And so that means the Rockies had a better run producing year. Also, I want to mention that notice I mentioned above the mean. If they were negative, then I would have said, let's say if it was negative 1.85, I would have said the Angels scored negative 1. Well, the Angels scored 1.85 standard deviations below the mean. So that negative versus it being positive will make a difference in how you analyze what occurred. Um, all right. Questions? Any questions? All right, scrolling up. Once again, if I scroll up and you were still copying or something like that, let me know. Of course, I can't see anyone. All right, so percentiles. The kth percentile of a set of data is a value such that k% of the observations are less than or equal to the value. So kth percentile is denoted by P sub k. Scrolling up. All right, so here Jennifer just received the results of her SAT exam. Her SAT math score of 600 is in the 74th percentile. What does this mean? So once again, give you a chance to write it. right. So that just means 74% of the people who took the exam scored 600 or less, and then 26% scored better. And you got that 26 from 100 minus 74. All right, any questions? Any questions? All right, quartiles. Let me put it up here. Okay, yeah. Quartiles divides the data set into fourths. So notice we have our minimum and maximum on the ends. Looking at this diagram right here, we have our minimum and maximum on the ends. But on the inside, you have Q1, Q2, and Q3. And so those are our quartiles, and they split up our data into fourths. So finding your quartiles. So what's key here is that, and a lot of people tend to forget this first step. So always make sure you hold true to it. It says list the data values from least to greatest. You always have to list your data values from least to greatest first. Then you want to find Q2, quartile 2. And that's going to be the median of the whole data set. So the median is your middle value. So don't forget how we would calculate our medians. Then we'll find Q1, which is the median of the first half of data. Then find Q3, which is the median of the second half of data. So really all you're doing is finding middle values. So you find the middle value of the whole data set first, then find the middle value of the first half of data, then you find the middle value of the second half of data. All right, your interquartile range, IQR for short, is the range of the middle 50% of the data set. So you'll find your interquartile range by doing Q3 minus Q1. All right, checking for outliers. Outliers, don't forget, are extreme values in reference to the data set. So you're talking about very, very large or very, very small data values in comparison to the data set. So what we're going to do is create these fences that will help us gauge whether we have an outlier or not, because we don't want to depend on our own sensibilities or our own vision to dictate whether something is an outlier or not. So we'll create these fences. We'll have an upper fence and a lower fence. And so if a data value is greater than the upper fence, then it will be an outlier. Or if a data value is less than the lower fence, it will be considered an outlier. So the upper fence will be Q3 plus 1.5 times the IQR, and the lower fence will be Q1 minus 1.5 times the IQR. All right, scrolling up. Erase some of this stuff. All right, so let's look at this data set and then find the quartiles and all the good stuff like that. So I've already listed the data set from least to greatest. So we have 180, 189, 370, 618, 735, 802, 1185, 1414, 1657, 1953, 2332, 2336, 3461, 4668, 6751, 9908, 10,034, and then 21,147. So now the way I decided to list my data, when I go to list my data values from least to greatest, first of all, I count out how many we have. And so we see here, we have 18 data values. So I write them in order, and then I split them up according to, first half and second half data. So I have 9 data values in my top half, 9 data values in my second half of data, my bottom half of data. So I would, list out 9 of them, break it up, list out the other 9. All right. So that's just, a good way of actually, being able to know or deal with first half data versus second half data versus just putting them all together when you go to list them from least to greatest. And you have to list them out anyway. So you might want to have a little strategy in how you list them to help you sort out your data values. And of course, they're not going to always come to you, already sorted or in least to greatest. All right. So now the first step, well, that was the first step. Second step is to find Q2. Now, Q2 is going to be the median of the whole data set. And notice we have 18 data values. So don't forget when you're trying to find the median, when you're trying to find the median, if you have an even number of data values, what you do is you take the 2 middle values, add them together and divide by 2. So there goes Q2. We took 1657 plus 1953 and divided by 2, which is 1805. And so, if you were to write your data values, first half, second half, split them up into 9 or something like that, whatever your number of data values are, it's easier to find your medians, especially when you talk about the median of the whole data set. All right. So next, we're looking to find Q1. And Q1 is the middle value of your top half of data or first half of data. So we have an odd number in the first half. We have 9 data values. So there's actually a middle value here, 735. And so be careful here. A lot of times people will leave out 1657 and 1953 because you use that to calculate Q2. Just because you use those to calculate Q2 does not stop them from being a part of the data set. So remember your median is 1805, which is in between 1657 and 1953. And so those are still a part of your data set, and they should be included as in 1657 as a part of your first half of data, 1953 a part of your second half of data. So that was Q1, and then Q2, not Q2, Q3 is going to be 4668. Once again, odd number of data values in that second half of data, so we're just picking out the middle value. All right, we can find the IQR by subtracting Q3 and Q1, and that gives us 3933. And now we can determine our fences. Doesn't matter which fence you find first. Here we have the upper fence calculation, Q3 plus 1.5 times IQR. So that's 4668 plus 1.5 times 3933. And that gives us 10,567.5. And then our lower fence, Q1 minus 1.5 times IQR, 735 minus 1.5 times 3933. And that gives us negative 5164.5. All right. So now we use our fences to determine if there are any outliers. The answer is yes. 21,147 is an outlier because it's greater than that upper fence. Remember, our upper fence is 10,567.5. All right, questions? Any questions? All right, so yep, that's it for 3-4. Let's do 3-5, which is very similar. And then we'll be done for today. All right, so the only difference between 3-4 and 3-5 is that 3-5 discuss the 5-number summary and the box plots. But in order to get to the 5-number summary and box plots, we have to follow the same thing we just did out of 3-4. So 5-number summary of these 5 numbers, your minimum, Q1, Q2, and well, Q1, Q2, Q3, and your maximum. So 5-number summary. And that has nothing to do with whether maximum or minimum outliers or not. Just that what is your max, what is your min, and then Q1, Q2, and Q3. All right, box plots, graphical tool used to compare groups of data. It consists of a box with lines that extend to the minimum and maximum values that are not outliers. So your book does a modified box plot wherein they don't extend to outliers. So we'll talk about that. Well, you'll see that when we do our calculations. These lines are called whiskers. All right. So your outliers are going to be represented by an asterisk. All right, and this is generically how your box plot would look. So notice we have a box with 3 lines in it. It will represent Q1, Q2, Q3, and then lines that extend from it would go, those are your whiskers, they would go to your minimum and maximum values that are not outliers. Then if you do have an outlier, it would be represented by an asterisk. All right. So the directions could just be give the 5-number summary and then sketch a box plot. So just a reminder, data set is not always written from least to greatest. And make sure you do this before you start to do your calculations. Where's this right here? Okay, so first up, just like before, list your data values from least to greatest. We have 21 data values in this case, so I'll give you a chance to write them. That 30.95 was our middle value. That's going to be Q2. So that's why I wrote, remember I told you that I strategically write my data values so that I have a top half data, bottom half of data. So that means we'll have 10 in the top, 30.95 in the middle, and then 10 down bottom because we had 21 data values. All right, hopefully everybody has the data set. Okay, so step 2, we already mentioned, find Q2. And like I said, that's your middle value. We had an odd number of data values. So that one was easy for us. Just pick out the middle number, which was 30.95. All right. So next, we want to find Q1. Now we have an even number of data values in the top and bottom this time. So we have to take our 2 middle values, 25.83, 26.28, divide by 2, and that'll give us 26.06. Then to find Q3, we do the same thing. 37.05, 37.43. Add them together, divide by 2. All right. So find the IQR, Q3 minus Q1, 37.24 minus 26.06. And that gives 11.18. Next, we want to establish our fences or determine our fences. Got an upper fence and lower fence. So lower fence, Q1 minus 1.5 times IQR ends up giving us 9.29. Q3 plus 1.5 times IQR ends up giving us 54.01. All right, and then in the red, just a reminder, if a value is less than the lower fence or greater than the upper fence, it is an outlier. So 54.63 is an outlier because it is greater than that upper fence. So any questions before we do a 5-number summary in our box plot? All right. So we're looking at a 5-number summary. Minimum value or smallest value is 19.95. Q1, 26.06. Q2, 30.95. Q3, 37.24. Then our maximum value was 54.63. All right. Box plot. So we will have our box with the 3 lines in it where Q1, Q2, and Q3 would be. Whiskers would extend to 19.95 on the left, but 49.17 on the right, because remember 54.63 was the outlier. So we would represent that as an asterisk. So the stuff in the red is what you normally wouldn't write. It's just me writing notes. The black is what will represent your actual box plot. All right. Questions. All right. So that's it for chapter 3. And so what you guys have now, hold on, is everybody done copying before I go to another screen? Anybody? Anybody? Okay, cool. All right, so to make sure you guys are straight with the topic you hear, we have assignment 1 on this left side, only 4 problems, 15, 13, 23, and 9 in those respective sections. So they're all odd as well, so you really shouldn't get an answer incorrect because the answers are in the back. But what I want you to do is to do them and then check to see if you got your answer correct. And if you don't have it correct, see if you can figure it out. If not, then you know you need to ask the question and get with me on whether it be in class or outside of class, email or Zoom session, independent Zoom session. But you have those 4 problems. Well, today is Monday, so I would say we do by next Monday. Just 4 problems. Like I said, they're odd, so you should be able to check your answers in the back and to make sure that you're able to get the answers that they have and make sure you're doing it properly. So that's just assignment 1 right here, 4 problems. All right, questions on that? And basically in each section is what we were doing. Like in 3.5, you have to do, the box plot and 5-number summary, stuff like that.
How do we turn it in?
Just write it out, take a picture, and then email it to me. That's fine.
Okay.
Mhm. Now, if anyone has issues, maybe not doesn't have a smartphone or somebody doesn't have a scanner, then make sure you email me so we can talk about other options. But that's just the easiest way to do it. Just take a picture with your phone, or like I said, if you have a scanner at home, you can scan it and then shoot me that email, and that'll be good to go. All right. Any questions, concerns, or comments before we close out? Even though we have, more time, I'm not going to jump into chapter 4. Next class, I will address questions, see if anybody has any questions first before we do anything else. But that is it for chapter 3. So just re-emphasizing that. And if you look at chapter 4 is only 3 sections. So I'm not going to try to knock out all of chapter 4 in one day, but I could. So just throwing it out there. Just make sure that you're on top of this work, chapter 1 and chapter 2. I mean, you knocking it out as soon as possible because you don't want to be in chapter 2 or chapter 1 still. And next thing you know, we're in chapter 6. So I just want to make sure I, keep reminding you about that. Questions? Somebody just unmute? Anybody?
Yeah, I just had to talk to you like after
Right.
class and stuff.
Yep, not a problem. Anybody else before we dismiss? Everybody good?
I was gonna say the same thing. I was having some issues sending out emails. Well, two of my professors said they didn't get my email.
Okay, okay. Well, let me close out and then I'll get with everybody. Anybody else? Any class things before we close? Because I don't want to record this stuff either. Pretty good. Okay, so if you're good, I'm good. I will see you guys on the next class and have a great day.